Hello, everyone. I just wanted to do this quick video to cover some of the material that we've been looking this week, as I know that we have few students who are for family reasons or other reasons out of state or have been unwell and unable to attend and so on. So I just wanted to make sure that we offer a resource for everyone to excel in this class. So having said all that, what I'm going to do, I'm going to share my screen as if it was a student view of our course. And of course, within the learning modules, that's where you go for all the material. And when we go to this week's material, you'll see that we were looking at the chapter on blood vessels. So I have provided a rather good review of the chapter content in the form of voiceover videos like I always do. So we discuss all of the key points of the chapter, and I think that those really help you to kind of see the emphasis, the level of the detail, and so on. The only thing not covered on those videos is the extensive distribution of both arteries and veins, and the major arteries and veins that I do want you to learn, especially when it comes to the blood vessel anatomy practice activity. So for this, I have actually, we did a little bit of an activity within the class, building a model in groups of different parts of the human body and what are the most important vessels to know for that. And like I promised in the class, I will be providing a copy of the diagram that you put together for everyone. To put this diagram together, we did use a resource that I have actually uploaded also here on your learning management system lecture handout of the blood vessel diagrams. And this is really a thick bunch of various different kinds of diagrams, both very schematic and anatomically more correct diagrams, covering the major arteries and major veins of different parts of the human body. And I did provide this in a printed copy, some in color and then rest in black and white for you in the class. So if you were in the class, you should have had a chance to receive a copy of that if you wanted to get a copy. And if you were not in the class and you really want a copy of that, now I'm going to leave it up for you to do the printing yourself. I think that the printing for this number of copies got a little extreme for me to manage myself. So that's a resource that I really encourage you to make available for yourself, and especially when it comes to the anatomy practice. You remember that your exam weeks, so we've got one coming in 2 weeks, the exam 2, and that includes also the practice anatomy or anatomy practical test as well. And these anatomy practice activities that we do each week build up on those practical exams. So I really encourage you to make sure that you take the time to do those, and you make sure that you have everything you need then to be successful in the actual practical exam. Having said all that, I was a little bit debating, should I go through the lecture material with you once more? And I really do think that we have the material up there on the video, so it might be a little redundant to do that. Instead, what I want to do with you is to go through key points as it relates to the lab that I asked you to complete. And this lab was all about measuring the blood pressure, doing a little bit of different conditions, and then trying to deduct more information about the blood pressure as it relates to these activities that you completed. So I'm going to stop sharing this screen and jump in to the actual lab worksheet for that, and we'll have a look of that together. But you will find the worksheet, you will find the videos that I will be referring to, and so on within this activity under the blood vessel assignments. So look for blood pressure in class activity for completing the lab for this week. And now just let me pull up another window. And this is the worksheet that I shared with you when it comes to what I'm expecting to get back from this week's lab. And as always, even if you work as groups in the in-person lab, I am expecting a lab worksheet from each one of the students individually submitted on Canvas, so that makes the grading a little bit easier. This worksheet includes 5 questions that I'm really looking for answers. So that will help you to kind of make sure that you address everything to the level in a way that I'm looking for. So let's move on. And I have another view, yet another view to share with you. And obviously, like I've shared before, there are going to be labs where you just simply have to be in the lab in person to be able to complete those. And I think that this is a lab that kind of falls in between that dry lab that you can complete independently at home and a wet lab where you need to be in the lab room. This has a little bit of elements of both. So I do not reset the labs so that you could come later on onto the class. That just makes the volume of the work unmanageable. So instead, what I do, I provide you at least some of the elements that you can complete independently. So like I mentioned, we completed a blood vessel diagram activity also in class. If you were present, you should be well aware of what that was, but our focus will be now on this blood pressure lab. And as always, I've provided on your Canvas, on your learning management system, kind of a rough idea how the points are going to be distributed for completion of this lab. And there's different kinds of conditions where I'm asking you to measure your blood pressure. And really the skill of learning to measure the blood pressure by using a pressure cuff and a stethoscope is one of the key practical takeaways from this lab. So I don't expect that most of you have stethoscopes and pressure cuffs laying around at home. So if you did not attend to the class, that is a skill that you should make sure that you acquire. However, from my point of view, when I'm grading the lab, if you are able to collect the data at home using something else like the automated home blood pressure cuffs, I would be open to that. But you have to go through that extra trouble of collecting that data. So all of those conditions carried a little bit of marks getting the blood pressure measurement towards your grade for this week's lab. But really where most of the marks come from is kind of doing a little bit of thinking of what those values tell you. And heavy emphasis on the grading is on the explanation part. So I'm really hoping you to collect data, then see some patterns of the data, and then explain why that might be the case. And as always, if you show up in person to the lab, you will have every single answer for every question available by the time we're finished. I might not give them, but we discuss them together until we get to the right point. So that's why I emphasize that coming to in person to the labs. But if you did not have a chance to attend, I tried to get you on a right track, and that's what this video is for. So if you watched the lecture video, this is gonna be, or lecture videos, this is gonna be very familiar to you. When we talk about blood pressure, that's a term that we often, many of us know, but we don't often stop to really think, what does it tell us? And one way to look at that is to consider here this sketch that I'm putting together representing our blood vessel. So whether it's an artery or vein, I think we're going to imagine in this case that it is going to be our artery. But you remember blood vessels had various different thicknesses of the blood vessel wall. And the blood inside this vessel will be pushing outwards towards the vessel wall. And this force, that how powerfully it pushes towards the vessel wall, is now what we can actually record as the blood pressure. So we're really looking at the force exerted on the blood vessel wall by the blood that's inside there. And typically some of the values that you will see for the blood pressure include two sets of numbers. And it will include a higher number and a lower number. And we'll discuss what results and why do we have actually two values that you need to know. Another thing that you'll notice is that the blood pressure is typically measured as millimeters of mercury. Mercury being the substance that you found in those typical old school blood pressure cuffs, and then climbing up on that little glass tube that looked a little like the old thermometers, if you wish. So let's have a look of this concept, why we are left with two values. And of course, this takes us back to talking about the heart. And you remember that we discussed that heart had this beating pattern where the atria contracted and ventricles contracted, but typically never were the both contracted at the same time. And this allowed the flow of the blood through the heart from one chamber to another. You remember that we wanted this flow to be synchronized, unidirectional, so going to one direction only. And we're now going to focus on the contractions of the ventricles only, because ventricle, and especially it's going to be our left ventricle that we're going to be looking at here. And you remember that left ventricle was thicker with the muscle wall, and its main function was to push the blood out of the heart, and it pushed the blood out of the heart to the systemic circulation. We had the little side story that we had a look of the coronary circulation as well, but we're now interested about the systemic circulation, the big arteries where the blood goes leaving the heart. And one of the things that we notice really fast is that the blood gets squashed out of the left ventricle in a pulsatile manner. So it's not going to be a smooth flow, but this flow rather is in response when the heart or the left ventricle is contracting and when it's not. So there's going to be an elevation in the pulse as the left ventricle, or elevation in the force of the pressure that the blood has when the left ventricle is contracted. However, it doesn't mean that there would be zero pressure when the left ventricle is relaxed. There is still going to be some pressure in the arteries. It's just going to be a little lower, but it doesn't really drop to zero pressure. So I hope that even though I kind of stumbled around there, that makes sense. Remember the pulsatile squeezing of the blood out of the heart. The other thing that we notice is that now if we focus on this pulsatile flow of the heart, well, that brings us to the concept of the pulse. And this was in response to the arteries expanding when there was the high amount of blood being squashed out of the left ventricle. So let's have a look at that first with the systole. So when the left ventricle really squeezes that blood out of the heart with great force, the artery walls will expand in response to that. So they're adapted to kind of be a little bit elastic, little bit responsive to that when a lot of blood comes out with a high force, well, these vessels will expand in diameter. And when the ventricles are relaxed, these vessels return back to their normal diameter. So when there is that high pressure, high amount of blood being squashed out of the left ventricle, we're in the state of systole. There is this expansion or enlargement of the vessel diameter. And when there is no force from the ventricle squeezing blood out, the blood vessels return to the normal diameter. That's going to be our diastole. So it is really this change in the pressures being exerted on these walls of the arteries that we're interested when we're looking at the blood pressure. And since it was pulsatile, this is actually what we will detect when we're taking someone's pulse, this change between systole and diastole. So how you're going to do this, or how you did this in a lab, is down to using two pieces of equipment. So already earlier on, we have talked about stethoscopes as a method to listen some of the sounds. For example, we looked at the heart. But just as well as you can listen to heart, you can listen these blood vessels, and in this case, the arteries, that do we hear this pumping pulsatile flow of the blood or do we not? Another tool that we're introducing to this process is now going to be your blood pressure cuff. And what blood pressure cuff does, it's able to exert pressure around your arm, but that pressure causes also pressure to the blood vessels that we're now interested on, so in our arteries. And they can actually put so much pressure that they stop the flow through that artery. And by manipulating the blood pressure cuff and the pressure within there, we can then detect that we can then from that in a reverse way work out that how much pressure there is inside that vessel at one time. And again, we're going to end up with systolic and diastolic number. So two numbers for that. You typically would place the blood pressure cuff around an artery at the arm. And it's important that you pay attention to positioning the tubing correctly so that you don't interfere with the process of what you're actually trying to do. And you place the stethoscope more distally to the cuff, so further away on that limb from the point of origin. Well, as you're inflating the cuff, like I said, that will block the blood flow to the distal parts of this artery, distal from the cuff. And you are listening for sounds that you can then deduct from there when the pressure is applied below the systolic pressure. So it's a combination of using these two tools, and it is really a skill. You need to be a little bit multitasking, a little bit using two different senses at the same time. And that's why this lab is really useful to do in person by using these proper old school resources, pressure cuff and a stethoscope. So what I show in a class, I show two videos where we actually start to see the process of manually taking the blood pressure with the stethoscope and pressure cuff. And we also listen for those sounds that I'm asking you to become familiar. And I'm only asking you to become familiar of two sounds. So we don't go into quite as much detail as all of the things that are covered in these videos. And I will include links to these videos to the end of this video that I provided for you, so you can go and look at those yourself if you didn't see them in a class. The links are also included in your lab worksheet or the assignment sheet. The reason why I don't embed them into this presentation or show them embedded in this presentation, that I want to be respectful for the people who have taken the time to make these videos and not take someone else's work, but rather to refer you to their work so that they get their clicks and they get their visibility and they get their credit for their work. So what am I asking you to do? One of the things that's going to be important for your success in this lab is that you make sure that the blood pressure cuff that you are using is of an appropriate size. If your blood pressure cuff is not of a correct size, that will have an impact on how successful and how great your chances of success in this lab and in this activity is. I do realize that resources are limited. So in the class, we had to kind of go back and forth and find the right cuff for each team that was working on this. You will place the blood pressure cuff around the upper arm, usually the cuff's lower edge about 1 inch above the antecubital fossa. And if you're kind of now thinking, oh, that language is coming back to haunt me, you are actually correct, because this is one of the terms that we discussed earlier on. So antecubital fossa referred to this kind of a triangular space within the fold of your upper limb, where the upper and lower part of that bend on the opposite side from the elbow. And this is the area where we often draw blood and so on as well. So this area, now that we know that it's called antecubital fossa, let's have a look of what you're trying to find there. Well, our interest is going to be on the brachial artery. And brachial artery was an important one for you to be able to identify. You might want to palpate it. You might want to locate it first before you jump into the whole process of putting on the cuff, putting on the stethoscope. And what you'll see is that brachial artery runs here nicely, crossing the antecubital fossa from one side to another. And it, in some people, is fairly easily visible and fairly easily accessible. On some people, you might need to do a little bit of detective work, but I do think that you will find it there. And as always, I was there in the class to help you to find it. Well, once you have the cuff on its place and once you have located your brachial artery that we just had a look of, what I asked you to do was to go with the pressure cuff to the pressure of 180 millimeters of mercury. And once you reach this pressure, you slowly started to release the air inside, kind of roughly on a rate of about 3 millimeters per second, so that we could see a few different things happening as you release this pressure. Don't go higher than 180. We don't want to hurt any of our volunteers. But what you're doing there is really listening with the stethoscope. And while you're listening, you're keeping your eyes on that, those values of what sort of a pressure do we have inside the cuff. And what I'm asking you to do is to notice first the knocking sound that you will start to hear at some point as you're coming down. This first time when you start to hear the knocking sound, that's going to be our systolic pressure. So make a note of that. And then as you keep releasing the pressure, that knocking sound will disappear. And this point where it disappears, again, make a note of the pressure within the cuff at that point. That's going to be our diastolic pressure. So I'm only asking you to really make a note of the two events that take place, or two sounds, even though those videos that I showed you and have included to the end of this go into far greater detail. It's really these two events that I'm asking you to pay attention to. And we're going to actually first start by simply making sure that you're able to get the blood pressure. And once you're able to get the blood pressure, we kind of up the game and start doing a few different things. I ask you to measure the blood pressure after the volunteer has been sitting down for about 5 minutes so that we know that they've reached that blood pressure that they would have in a sitting position. Do the same after the volunteer has been standing for 5 minutes, so that should have an impact on the blood pressure. And finally, we do it again for a volunteer that has been laying down for 5 minutes. Of course, it's going to be best if you can use the same volunteer for all of these conditions, even if your measurement isn't perfect. As long as it's consistent, you will get the difference, the change in the blood pressure values, depending on these conditions. That's what we're after. And as you work through that, one of the things that you probably will notice, and most of my students notice, that there is a difference depending on what position you were. So the body position does have an effect on the blood pressure. And we saw that especially if we compared the values from standing to laying down. And then in the class, I asked you why. This is the question that carried the most points. I think it was 5 points out of 10. So half of the lab's value is going to be about you being able to reason why these different body positions will alter the blood pressure. So we're really now kind of going into digging on that information that we learned about the physiology of the blood pressure on this chapter. And if you were in the class, we continued this discussion until we got to some of the right answers for that. And if you were not able to be in the class, I will refer you back to those lecture videos that I provided for you. The answer is there. The big thing, I guess, is that I'm not asking you to write a full essay on this. I'm simply asking simple to the point answers. It can be sentence, couple of sentences. Don't make it a bigger of a deal than it is. So just wanting to put it out there. And that really was our lab and what we did for the lab this week. Like I said, do not forget though that it is important that you take the time to learn about the major blood vessels in the body. So it's important that you spend a little bit of time going through that handout that I provided for you in the class. And if you were not in the class, make sure that you download that or at least have a look of that from our Canvas course. And like I said, you will find that handout here as the lecture handouts for blood vessel diagrams under the blood vessel lecture and notes. As always, you will submit your work for the lab through the blood pressure in-class activity. And when you click on there, this is where you download the worksheet. I always provide these printed in the class if you show up in person, but once you've completed it, then you submit it here through the assignment area. The two videos that I spoke about are also found in there. Just a quick shout out. Do remember that I'm also asking you to complete, as every week, a blood vessel quiz and blood vessel anatomy practice. I know that it takes a little time to work through the quiz, but that really is a learning opportunity. It's not something that I'm putting it out there as saying that you need to know every answer to every single blood vessel quiz question. It's more of there that as you work through that makes sure that you have covered everything you need to know for the this week's learning material. I hope that has helped you. As you see, there's a bunch of other material as well that I offer to you on the course learning, interactive learning environment. And remember that to help you with the blood vessel anatomy practice, there is a video kindly prepared by one of my colleagues made available for you that will actually discuss those. So I strongly encourage you to take a little bit of time to have a look of that as well. And that really completes everything that I had for today. Like I said, one thing that we have not gone to in detail is the actual presentation of the actual, I guess, teaching that I do in the class. So I'm just leaving that for you to go through it independently from those videos that I provided for you. I think there's a bit there of information to go through, but I think it's going to be super useful information for you to go through. So again, bearing in mind that some amount of independent work is needed, especially if you miss the in-person class. So I hope that this video has been useful. I appreciate each and every one of you so much, and thank you for your hard work in this class. And I look forward to seeing you next week when we move on to talk about lymphatic and immune system. And that really will kind of nicely wrap up and connect to what we have been talking about the blood vessels this week. So having said all that, thank you again. I hope you have a very good long weekend. Enjoy your time off on President's Day. And for anyone who's wondering, of course, college is going to be closed for the President's Day. So if you have any classes, whether it's with me or someone else, that would not be something that I would be expecting you to do to show up unless other arrangements have been done with your individual instructors. Okay, thank you. Have a good weekend. Bye.